Alright, so today we're going to talk about hyperbolas. You see here I have a general form 4x squared minus y squared plus 8x minus 4y minus 4. Now, the first thing before we go on to solving this equation and turning it into the standard form is we need to look at the two different types. There are two types. One I call a horizontal hyperbola because it crosses the horizontal axis like so. And then one I call the vertical hyperbola because it crosses the vertical axis. So now this basic equation, or the standard form for this equation, is x minus h squared over a squared minus y minus k squared over b squared equals 1. Now if you notice, the x is first here for the horizontal hyperbola, which crosses the x-axis. Here, when it crosses the y-axis, we notice that we get the y first. So y minus k squared over b squared minus x minus h squared over a. That should be b. This should be a. Equals 1. Alright. So from there, we also need to look at how to find the foci. Okay, that is c squared equals a squared plus b squared. We obtain that from right here or right here. And c is going to equal the distance from the center, which is h comma k, to the foci horizontally or vertically. If it is horizontal, that means you're looking at a horizontal. If it's the distance horizontally from the center, you're looking at this one right here. If it's the distance vertically from the center, you're looking at a vertical hyperbola. Alright, so now let's go back to our equation. What is it? 4x squared minus y squared plus 8x minus 4y minus 4 equals 0. Now we look right here. I'm going to rearrange this. 4x plus 8x minus y squared minus 4y equals 4. Then I factor out a 4 because I want the x squared term by itself, plus 2x minus y squared plus 4y. Notice I factored out the negative, so both of these became positive, equals 4. Now I leave a space here for the completed square part. So half of this term right here is, so half of 2 squared is 1. Half of 4 squared is 4. And then I look, 4 times 1, so I added this 1 here, but I have this 4 on the outside, so it's really 4 times 1, so I have to add 4 over here. Here I added this 4, but it's minus. So, as I was saying, the negative times that 4 right there means minus 4 on the outside. So then this becomes 4 times x plus 1 squared minus y plus 2 squared equals 4 plus 4 minus 4 is 4. And now I want to, if you notice up here, I have it equal to 1, so I'm going to divide by 4 on everything. And I get x plus 1 squared over 1 plus, that's minus y plus 2 squared over 4 equals 1. Now I am ready to graph my hyperbola. Alright, so now we have our equation. X plus 1 squared over 1 minus y plus 2 squared over 4 equals 1. So, let's find, what we're going to try to do is we're going to find our center. We want to find our vertices. we want to find our foci, and we want to find our asymptote equations. Okay, well, our center is easy. That's obtained from right here and right here, and we do the opposite, -1, -2. Okay, so now let's go to graph this. Okay, so I'm going to make my graph and go to -1, -2. There's my center. Okay, from there I'm going to count vertically and horizontally by this term. Well, that right there is a squared, and we know that a squared equals 1, so a has to be plus or minus 1. So I'm going to go 1 to the right and 1 to the left, and then b squared equals 4, so b must be plus or minus 2, so I go up 2 and down 2. And the way I know I'm going horizontally and vertically is I notice that the 1 is underneath the x variable, and the 4 is underneath the y variable. X is the x-axis, that's the horizontal axis. Y is the y-axis, which is vertical axis. Okay, so I then draw a little box, and what this helps me do is I can get my asymptotes from this box, and that's going to help me draw the graph. Okay, so there are my asymptotes. These points right here are my vertices, because this is a parabola. It's going to look like this. I know that because it's that x squared is the positive term. So then I draw my graph. I'm going to use a different color to make it kind of stand out. Let me look right here. Notice they start from the vertices and they follow the dotted lines right there, those asymptotes. But they get really close but don't touch. They almost look like they're touching. Okay, so there are my asymptote, or that is my graph of a hyperbola. Now to find the vertices. Your vertices are these points right here, because they are on the graph. And that point is -2, -2, and 0, -2. Now my foci. To find my foci, remember I used that c squared equals a squared plus b squared. Well, then that means that a was 1, b squared was 4, so c squared equals 5, so c is going to be plus or minus √5. So my foci are going to go from here out √5. And √5 is about 2.2, so I'd go out 2.2. About 2.2. So these are going to be my foci. Well, alright. So now, we look, and I have that. So then, I said it was going to change from the center, and it moved from the center horizontally to get the foci. So that would be -1 plus or minus √5, comma, -2. Now my asymptote equations. Well, for the asymptote equations, you're going to use, I use point slope form. Y minus k equals m times x minus h. But instead of y1 and x1, I use h and k because they go through the center right here. So my asymptote equations are going to be y plus 2 equals, my slope is up 2 over 1 for one of them, so that would be 2 times x plus 2, which if you notice, this distance, the up 2 over 1, well, there's your 2 underneath the y, x is over 1, so I get that really from a and b. The number underneath the y value gives you the rise, and the number underneath the x value gives, or the square root of these numbers gives you the rise over the run. And then it's y plus 2 equals, I go down and over 1. So that would be a negative 2 times x plus 2. And now I have all the information I need for my hyperbola.